Well, the fine folk over on Patreon liked the last naval engineering failures video I did so much, they've asked me to do another one. So I guess here we go. At least this time we only have 5 ships to deal with. Since we've covered some of the more obvious disasters, these will be a few of the more subtle failures when it comes to how to build a ship and have it be useful in its role, although you might be surprised at the underlying current of just how bad some of these ones were. So, starting off in no particular order, we have Nuestra Señora de la Santísima Trinidad of the Spanish Navy in the Age of Sail. Now, often lauded as the biggest and most heavily armed ship of the line in the Napoleonic Wars, by the time that particular conflict actually really took off, her length and breadth dimensions had actually been exceeded, if only just, by the French Océan-class ships of the line. She did, however, carry a lot of guns, somewhere between 130 and 140 guns, depending on your source and which year she's in, but this on-paper firepower concealed several major issues with the ship. At the start of her life, Santísima Trinidad had been a notionally 112-gun 3-deck ship of the line, and a relatively decent one at that. Her sailing capabilities weren't the best when you compared her to a ship like HMS Victory, but then the latter was seen as an outstanding sailor for a ship her size. What Santísima Trinidad did have, overall, was size and durability. Built of mahogany in the excellent Havana shipyards, she could, and later did, take an absolutely massive battering and remain at least somewhat operational. Although not a direct ancestor in design terms, the lessons learned in her construction would play into future Spanish ships of the line, including the rather excellent Santa Ana class. Where it all started to go wrong was in the early 1790s, when somebody had the bright idea to join the forecastle and quarterdeck together to create a continuous 4th gun deck, with now just the poop deck rising above her deck lines. Although this technically allowed for the installation of more firepower, the two biggest problems were the nature of this added firepower itself and the effects of the new structure on the ship. Looking at the structure first, the additional weight meant that her lower gun deck now sat closer to the water than previously. On first rates generally, this had always been an issue to some degree or another, and even on ships with a decent amount of clearance, reducing this down by adding weight up top could be problematic. On a ship with average or worse clearance, it could be a much larger, potentially fatal issue, but either way it restricted the use of the lower gun deck, and with it the heaviest guns, to calm or light seas. Anything heavier, with waves that exceeded maybe 3 to 6 feet in height, and some or all of those gun ports would have to be shut, thus reducing the ship's firepower quite considerably, as each one of the 36-pounder guns on the ship's lowest gun deck fired a shot that, in weight terms, was worth 4.5 of the long guns that were ranged on the length of the new 4th gun deck far above. Additionally, with so much additional surface area and weight up high, the ship turned into a very poor sailor. While some Spanish propaganda of the time liked to call her El Poderoso, the powerful one, many of her crew preferred El Ponderoso, the ponderous one, or as one contemporary British writer put it, a ship with the sailing qualities of a barn. This was because all that weight up high made her roll considerably more than she had originally been intended to, and the surface area meant that her hull acted more like a sail in and of itself. And of course you couldn't change the direction of the hull or furl the hull sides, and this meant that attempts to change course would be met with the ship's own hull area trying to push you back downwind, and the sails and rigging, which were designed to move a somewhat lighter 3-decker, struggled to make her go anywhere fast in the first place. This made it much harder for her to bring her guns to bear on target, and it made it much easier for smaller and more nimble enemies, which was essentially anyone, to simply stay out of the broadside's arcs if there was room to manoeuvre. And it also made it much harder for the ship to escape if the situation called for it. Even a comparatively small loss of sails and masts could almost immobilize her, and that was before she tried to hold formation with other ships, which probably took several years off of the collective lives of nearby captains, with the stress of wondering where exactly the gigantic floating castle of guns was going to wander next. And that brings us on to the firepower issue. The new gun deck carried two kinds of weapons, the 8-pounder long gun and the 24-pounder obus. The 8-pounder was self-evidently a very light weapon, light enough in fact that even at conventional battle ranges for Age of Sail fleets it might struggle to make it through the heavily built sides of a typical ship of the line, and with approximately a 4-inch shot diameter you couldn't fit all that much in terms of anti-personnel ammunition in there either. Similar weight guns, like 9-pounders, did exist on the British side, but you typically only found a 9-pounder on a very lightly built warship, usually an unrated one. The corresponding upper-level guns on HMS Victory, for example, which are obviously out in the open for the most part, were the somewhat more powerful 12-pounders. So going through all the extra weight, expense and time to fit a large number of 8-pounders as the fourth gun deck's worth of firepower would be a little bit like adding an entire extra level to the superstructure of a modern destroyer just to install a brand new CIWS battery made up of .22 long rifle firing Gatling guns for self-defense against something. Maybe seagulls? The 24-pounder obus was perhaps a somewhat better idea. In response to the growing use of carronades by the Royal Navy, which were short-barrel, lightweight alternatives to cannon, which could normally be found in the upper reaches of a ship's decks, as they could fire a substantial shot, usually 24 or 32 pounds, but sometimes even 42 pounds, but over a reduced range, the Spanish and the French had adopted the use of short howitzers, called obus in Spanish, or obus, and obusier in French, at least I think. These were typically even shorter and made of bronze or brass. Although relatively lightweight, this is only in comparison to a full-size cannon. A 24-pounder obus still weighed about 3/4 of a ton. In principle, this formed a neat answer to the British. In practice, though, the relatively thin and extremely short barrels were really only suitable for throwing the much lighter weight explosive shells, which of course are considerably less straining on the barrel than solid shot, or grape and canister shot, and both of these would be hurled at short ranges. Now you might think, oh, a bunch of shell guns in the 1790s, that's a brilliant innovation, and indeed it would be. But these weren't cannon that fired shells in roughly a direct line of sight, they were howitzers, which meant that to hit anything with a shell, you'd first have to find yourself guessing how far above the tallest mast of the target you actually had to fire, and then pray that the rolling of your ship and the delay in the charge going off between you lighting the fuse and the actual detonation didn't completely throw off an already quite sketchy firing solution, since of course a round plunging down out of the sky had to be on target by a handful of degrees at worst, whereas the mostly horizontal firing cannon could be out of aim by as much as low double digits, and they'd still hit something, assuming you aimed for, roughly speaking, a ship's centre of mass. As a result, by the time of Trafalgar, the French had actually largely removed their versions, but the Spanish persisted with them. It seems as anti-personnel weapons, which is borne out by the fact that there's a total absence of any mention of exploding shells at Trafalgar. With no less than 16 of such weapons installed when she fought at Trafalgar, Santissima Trinidad might seem to be onto something. But here her great size now once more worked against her. With such high sides to her hull, there was precious little chance of an opposed boarding action succeeding, and so the Royal Navy decided, much as they had done at the Battle of Cape St. Vincent, to simply pound away at her in a manner that was more like a castle under siege, i.e. large amounts of cannon shot from range. This meant that the obus crews usually lacked the reach to inflict any damage on their opponents, whilst at the same time being subject to prolonged hails of fire from the enemy long guns, cutting down the gun crews to the point that if any of the British three-deckers had drawn alongside for a boarding action later in the battle, there probably wouldn't have been that many operational obus to oppose them. The sum total of all of these issues was that in the two major actions she fought after her refit into a four-decker, she came off considerably the worse in both of them. At the Battle of Cape St. Vincent, she was besieged and then struck her colours, only saved by the intervention of a more sensibly designed Spanish first-rate and a third-rate, which took the big ship under tow. And of course, years later, she would of course be present at Trafalgar, and in the light winds, the helmsman might as well have put his feet up for the day, as she just gently drifted forward, essentially out of control, being once more besieged, briefly interrupted by a slightly confused party from the tiny 64-gun HMS Africa, who turned up to see if she had in fact surrendered, before then actually surrendering sometime later, and then being lost in the subsequent storm that followed the battle. Speaking of poor seakeeping, the F-class escort ship, or Flottenbegleiter. This poor benighted class of 10 ships are often termed fleet escorts. The F-class, as I shall call them from now on, were a strange concept to start with, even before they were weighed down by a navy which tried to make them capable of fulfilling almost every role you could possibly ask of a small vessel, while stuffing in an insanely overpowered set of engines, to the complete and utter failure of the type as a whole. That's a mistake that's so monumental, surely no one would ever want to repeat that again, right? Well, believe it or not, the F-class origins lay in the idea of providing escorts for the Panzerschiff, the German 11-inch armed heavy cruisers, which were intended for long-distance diesel-powered commerce raiding. Quite why anyone thought they'd need or want pint-sized companions is another matter, but regardless, this meant that they'd need to match the speed of Deutschland, Admiral Scheer and Graf Spee. In itself, the concept wasn't terrible, but it would suggest that such a vessel would need to be somewhat larger than a destroyer in order to be able to fit long-distance diesel engines and/or substantial fuel stocks, definitely substantial fuel stocks if they were going for turbine power, as well as a decent deep hull for seakeeping in the distant oceans and for storing lots of supplies. Instead, the Germans decided that these ships should also be able to act as minesweepers, either when they were off duty from escort roles, or if they were on duty and the raiders encountered enemy minefields during their travels. Except, of course, minesweeping needs a shallow draft hull, and ideally a relatively small, light and nimble ship. They were also designed when Germany was at least paying lip service to the Anglo-German naval agreement, and so they needed to at least look like they came in at under 600 tons to avoid being counted as part of either the Kriegsmarine's destroyer allowance or being in breach of Article 8b, which allowed for ships up to 2,000 tons, but those ships were limited, amongst other things, to speeds of less than 20 knots. This left the design team trying to square the circle of a ship which displaced around 700 tons, was supposed to be able to hit 28 knots, have a long range for operations in the deep sea, but also be a good minesweeper, and also, just as a side hobby, provide a degree of anti-aircraft and anti-submarine defence. To make at least a start on things, the only way to get the tiny craft up to the speed necessary with the limited hull volume caused by a draft of just over 10 feet was to cram in a stupidly high-pressure power plant. Most of the ships in the class would carry boilers that ran at no less than just over 1,600 psi, with two given slightly saner 1,000 psi units, at a time when the US Navy was considered to be operating particularly high-pressure boilers at what seems to be now a rather pedestrian 600 psi. These boilers would send about 14,000 shaft horsepower, which is about as much as a typical pre-dreadnought battleship's output, and pre-dreadnoughts outmass these F-class boats by about 22 to 24 times through a pair of screws. Onto this vessel was now slapped a handful of depth charges, a pair of single 105mm guns, one at each end, capable of just enough elevation to make you think they could be used to engage aircraft, but also not really, as well as two pairs of 37mm bolt-action anti-aircraft guns and a pair of single 20mm. These were for the actual anti-aircraft work. If the enemy was, of course, kind enough to approach at walking pace so that you could hand-load each of your 37mm rounds, the entire thing was coordinated through a single 9-foot rangefinder and portable units that you could pick up and run across the bridge with if the enemy aircraft happened to go to the other side of your ship. Somewhere on the quarterdeck, somebody remembered, yeah, there's supposed to be minesweeping gear here, isn't there? So they stuck a crane on to handle the sweeps. A total of 17 ships were initially planned, but as mentioned at the start, you only ended up with 10, the others being replaced, at least in theory, with a design for 10 actual minesweepers. Shockingly, reports from the trials were not favourable. Due to their small size and comically low freeboard, especially when you looked at their bows, the reports listed seaworthiness as just about adequate in a calm, as in these ships would not immediately be at risk of sinking. But outside of said flat calm, most of the spray from the bow had a disturbing tendency to launch itself right at the bridge, and above Sea State 4 they were bobbing around so much that minesweeping was essentially impossible. The anti-aircraft guns were also directly in the path of the near-constant shower of spray, and thus were barely workable, and thanks to the significantly greater resistance that resulted from all of this, range was also insufficient for deep ocean operations, something we'll come back to a bit later. Oh yeah, and the machinery had two settings: broken, or putting out so much power that the hull started to warp slightly, thus breaking everything else. About the only bright spot was that when they were capable of moving, their speed meant that they at least made passable sub-chasers. It was just a pity that their depth charge loadout as designed was best described as a generous handful, and so with a hopeful note that maybe in time they might not break down quite as much, it was proposed to repurpose them as escorts for the faster merchant ships running nearby to Germany, which is where much of the post-war designation issues as to what their actual role was supposed to be comes from. Now, on top of this came a final true tabulation of their capacity for range. Now, assuming that they moved at a reasonable speed, as opposed to a slow, efficient cruising speed, they could stay out for a grand total of about 3 days. Yeah, you ain't escorting a Panzer ship on that kind of range. After a consideration of trying to build an improved class, it was concluded the whole idea was stupid, and the role would be better filled by older torpedo boats, where you could just take off the aft guns and put anti-submarine equipment on there. A final report assessed them in their 4 main roles. In the fast escort role, they were evaluated as too slow, too short range, and had poor seakeeping in mild to rough weather. As a minesweeper, they were held to potentially be useful, but their draft was too great, which was a bit of a problem when you're sweeping mines. For anti-aircraft use, they were held to be too lively to be a stable gun platform, and for anti-submarine work, they were held to be potentially promising, but they had no hydrophones or any other way of detecting a submarine installed. Some efforts were made to fix the absolute worst of the problems. Eventually, the bows would be altered to reduce spray. The aft 105mm gun and the 37mm guns were removed, in the latter case replaced by 2 more 20mm, and various other additional changes were made to individual ships when they were repurposed for specific tasks. With this done, they were all promptly exiled to Baltic duty, which was the Kriegsmarine's way of saying the ship is incapable of being trusted in the open ocean, where inevitably they would be joined by the Königsbergs. The outbreak of war did see them briefly return to Kiel, but with the destruction of F9 at the hands of the submarine HMS Ursula and a string of mechanical issues, by March 1940, not a single ship was operational, and they'd spent so much of the intervening time adjacent to the pier outside Kiel railway station that they became known as the Bahnhof Flotilla, or Station Flotilla. Despite war needing pretty much every ship that floated to go out and do its duty, the laundry list of issues that needed to be fixed on them to make them even halfway workable was so long that they were instead just flat out removed from frontline services and spent most of the rest of the war in secondary roles, mostly as tenders, occasionally as training ships or torpedo recovery vessels on the U-boat exercise ranges, and very occasionally some bright spark would bring them back for escort duty until something broke, at which point everyone was reminded why they'd been taken off that duty in the first place. Oh, we have a bit of a theme developing around unsatisfactory seakeeping as we move into our third category, the Cyclops-class coast defence ships. Now, described by some as the most unsatisfactory group of ironclads to ever fly the White Ensign, the surprising thing is the Cyclops class actually started out as a repeat of something that was quite successful, the harbour defence ship Cerberus, built for the state of Victoria in what would later become Australia. The problem started in late 1870. The Russian Empire had taken advantage of the Franco-Prussian War to declare that it was denouncing and no longer following various clauses of the treaty which had brought an end to the Crimean War. They'd never been particularly happy with that treaty anyway, which was at least somewhat understandable since it had been negotiated under the multiple barrels of Anglo-French guns, but they saw the Franco-Prussian War, which France was not doing particularly well in, as obviously occupying one of the two major powers they'd previously fought, and they gambled that Britain, which was getting a front row seat to the two most powerful armies in Europe beating seven bells out of each other, would likely be distracted and not want to risk going it alone with Crimean War Mark II ironclad Boogaloo. This, in turn, caused no end of debate in British political circles, but the general reaction was actually quite aggressively against Russia redressing what Russia felt to be historical wrongs. And that, of course, seemed to point to war, because the Russians were, at least initially, not really giving in. And although the Royal Navy was the largest navy on the planet, the advent of steam ironclads in various forms meant that all new types of warfare were being dreamed up. In particular, the idea of Russian ironclads and other ships making a rapid passage from the Baltic to attack the British coast was envisaged by certain people. The whole situation was described at the time by Spencer Robinson. During the war scare of 1870, when there was a possibility of this country becoming involved and our ports subjected to enemy attack, the board had to consider the question of local coast defence against the kind of vessels, and how they would be armed, which would attempt the destruction of the large commercial and manufacturing towns which were situated on our coast. No large, heavily armoured, deep-drafted ships of war can approach the most defenceless of these harbours. A serious attack would have to be made by light vessels, probably a mixture of armoured and unarmoured ships. And you will easily see that the superiority on all points rests with the class the Admiralty adopted as part of a system of coast defence. The class he references would be the Cyclops class. For reasons best known to themselves, the Admiralty Board decided that the best way to defend the entire coastline of the United Kingdom and its various ports was not to blockade the Russian fleet, or blockade the exit from the Baltic, or even try to intercept and destroy the slightly weird shallow draft attack fleet as it might try and cross the North Sea, but rather they preferred to quickly construct a small force of 4 coastal defence ships, which would then be based along the coast and in theory able to sail to whichever ports the theoretical Russians happened to be going after. In the interests of time and cost, because they thought war could break out at any moment, the Cerberus type was selected and 4 ships were laid down in September 1870, Cyclops, Gorgon, Hecate and Hydra. Armament, armour and overall dimensions were pretty much identical to Cerberus, but the earlier vessel had engines capable of just under 14,000 indicated horsepower, which gave it a top speed of just under 10 knots. It was decided to instead install new engines that averaged around 1,700 indicated horsepower, although it varied per ship, for a top speed of about 11 knots. But these heavier engines led to the already small freeboard being reduced still further. Collectively, all the weight additions added almost a foot to the ship's drafts. The slightly larger superstructure that was installed didn't help in this case. On top of that, the new machinery turned out to need more men to operate, and so the overall result was a somewhat worse version of Cerberus, with the essentially non-existent freeboard liable to become awash in even the mildest sea, or perhaps the passage of a particularly corpulent swan. In and of itself, this might not have been awful, but considering that Cerberus was only expected to defend the harbour that she'd been sent to, with special additional temporary breastwork being installed on her deck for open passage in the ocean, and since there were more than 4 ports in the United Kingdom, these ships would be expected to sail in the North Sea in any weather, since of course attack could come at any time, and thus they were designated coastal instead of harbour defence ships. Being expected to travel and then also possibly fight at sea, combined with their already overloaded nature, was a fool's errand. And to be honest, many at the time realised it, with one admiral writing that the constructive department was ordered to build ships that could easily be run over in mid-ocean, which could not possibly float in shallow water, that could not go from one port to another, except after careful study of the barometer, that could go to the bottom readily in a very heavy seaway and in a variety of other ways, and that possessed the smallest amount of offensive power and the maximum amount of defensive power. That problem the constructive department has solved very faithfully and exceedingly cleverly in giving us coast defence ships which cannot defend our coasts. And what on earth do coast defence ships mean anyway? Although Cyclops entered the water only 10 months after being laid down, the war scare of 1870 was already dying down, and so the ships took their sweet, sweet time about entering service, since more serious warships now became something more of a priority. A review into the class concluded that, unless the weather was absolutely flat calm, they should never leave the shelter of a harbour, which completely negated the entire point of building them. As such, they remained pretty much immobile in the various ports that they were completed in until the late 1880s, when work was done to permanently extend the breastwork out in a manner somewhat similar to the layout of HMS Devastation. This provided more space aboard, as well as more buoyancy and stability, which allowed them to make safe sea passages on various exercises in the late 1880s and 1890s, well after their utility had passed, at which point they were essentially just serving to beef up the numbers, before they were sent back into the reserves and scrapped in 1903. And now we come to, well, the Sovetski Soyuz. Now, much as I criticise many German warship designs of the Second World War as inefficient at best and downright dangerous to their own crews at worst, you have to admit they were working from a handicap of enforced stagnation in their design departments for just over a decade after the Versailles Treaty, so some mistakes are to be expected. Now, Soviet Russia. Not only had serious warship design here collapsed earlier, with the outbreak of Dance Dance Russian Revolution, but the various factions vying for power had, much like the French revolutionaries about 130 years earlier, managed to either execute or force into exile a pretty good portion of the segment of society that made up the Russian Imperial Navy's officer and design cadres. Civil war then saw the destruction of much of the industrial infrastructure that was needed to build and maintain ships, and Lenin's government saw anything beyond coastal defence as a bourgeoisie concept, oddly echoing the sentiments of some of the elements of very early US government. And when Stalin came to power, the purges began. When interest in the Navy finally picked up again, design was mired in numerous committees, often with self-referential loops that went back over and over and over on themselves, and it was all subject to the change at the whim of Stalin himself. This complete detachment from reality meant that when new battleships were called for, the smallest of them was sketched at 43,000 tons, with the largest being a 75,000 tonner that would somehow carry no less than 16 17.7-inch or possibly 18-inch guns, along with a 15-inch inclined belt and a speed of 26 knots, even though it came with a note that Soviet industry couldn't actually produce a 15-inch thick slab of armour steel at that point, but they hoped that just sticking two slabs together in roughly the same area should be fine, in contravention of every engineering principle known to mankind. I'm sure the Japanese, who at that point were getting well stuck into their Yamato project, would have had quite a good chuckle at reading that particular ship's design notes. Drafts, proposals, specifications and sketches pinged back and forth and back round again between at least 5 different design committees, with notes about 20-inch and 21-inch guns and 20-inch thick belts being whispered about in certain circles, before settling, after quite a few ups and downs, on something just under 60,000 tons, with roughly speaking Yamato-like speed and protection, but with 9 16-inch guns instead of 9 18.1-inch guns. And all this for a nation's first battleship building attempt since the middle of World War I and the early Dreadnought period. Stalin then happily launched another purge, and most of the design teams promptly turned on each other, with the survivors forging ahead with a series of ever-increasingly interesting design decisions. They decided, for example, to include a Russian version of the Italian Pugliese torpedo defence system, and then only after the ships had actually started construction did they bother to do a comparative test to see if they were actually correct, The Italian system required extremely fine precision workmanship to function properly, and so unsurprisingly their bootleg copy fared much worse than either the original Italian system or the multi-layered system used elsewhere, but since it was too late, the ships continued with a torpedo defense system that probably would have failed the minute it was hit by any substantial torpedo. Aerial bombing tests were then conducted on a target, which concluded the deck armour needed to be moved up higher. To mitigate against the effect on stability, and because the belt armour would need to be taller and thus heavier, the belt was thinned by about 2.5 inches, only for the original thickness of the belt to later be ordered to be readopted with absolutely no mitigation for weight or stability included. Model tests on the hull form showed a wide range of issues. At certain speeds, the bow wave series of crests and troughs along the side of the hull would expose the unarmoured hull below the belt. It was decided this was clearly unpatriotic behaviour by the water and ignored. The ship sat very heavily aft, so they reduced the height of the belt armour in the aft area and removed the 2 aftmost heavy anti-aircraft turrets. This mitigated but didn't entirely solve the trim problem, and then the turrets were ordered to be installed back into the design later anyway, again with no mitigation. And so it went on. The ships were ordered to be laid down before their final designs had actually even been finished, and were supposed to enter service in about 2.5 years, which was an absurd target even for a country that actually knew what the heck it was doing. Steel only arrived sporadically, and much of it was of such low quality it was outright rejected even on a cursory visual inspection, and it turned out that half the factories who were supposed to be building such minor things like the turbines, the boilers, the propeller shafts, and the gun turrets either didn't exist, were incapable of conducting the work assigned to them, or they could do it, but they were extremely slow. And then one of the ships had to be cancelled because they found that a lot of the rivets they used were completely substandard and would probably have failed shortly after she hit the water. And that's just the edited highlights of the cavalcade of stupidity that was the Sovietsky-Soyuz design process. All in all, the German invasion leading to the halt of the project was probably a mercy for everyone involved, as the cumulative list of issues meant that there was a non-insignificant chance of the ships managing to just sink themselves in bad weather, if any of them had ever been completed, and if they faced actual combat, the skill on the enemy's part would have been in not hitting a weak point. Now, after all that, we come to USS Wasp. And you might be thinking, oh, come on, poor old Wasp can't possibly be that bad compared to Sovietsky-Soyuz. And, well, you'd be right, she wasn't. But she still represented an engineering failure in the end, albeit for reasons that are at least somewhat more understandable, even if there were also some rather clear missed opportunities. Wasp came about thanks to the naval treaty system. USS Langley, America's first aircraft carrier, was being converted to a seaplane carrier, and that meant that between her coming off the books as a carrier and the rounding up of odd tonnages from the Lexingtons, Ranger and Yorktowns, there was about 15,000 tons to play with in the US Navy's carrier tonnage allowance. It was decided to therefore design a carrier which would use up every last one of those tons. Unfortunately, 2 things immediately saddled the design. The first was an overwhelming desire amongst many of the US Navy's higher-ups to get the same or as close to the same capabilities air group-wise as the larger Yorktowns, just on a smaller displacement. And much like the Hatsuhara-class destroyers in Japan, it would turn out that could only be done with rather significant corner cutting practically everywhere else. The other issue was that there was, in theory, a way out of this problem. Back when Lexington and Saratoga had been converted, the US Navy had, upon realising how overweight they were going to be compared to the new treaty restrictions, engaged in quite a bit of creative accounting and incorporated what was supposed to be a 3,000-ton allowance for mid-career upgrades into the ship's initial starting tonnage, then quietly shuffled under the carpet the fact that the 2 carriers came in even above that limit, if you happen to look at them closely. Now, no one had really challenged them on this, and so in theory at least, a similar trick could have been used to rack Wasp up to essentially a repeat Yorktown with the serial numbers filed off and maybe a few aesthetic changes that looked like weight-saving measures. But this wasn't done. Instead, the designers were told to forge ahead with a carrier that possessed a Yorktown-scale air group on a hull that displaced somewhere between 3/4 and 4/5 as much. Oh, and they had to start on all of this before Ranger commissioned, before Yorktown's final design had even been completed, so they had exactly zero real-world feedback on how the various features that had been designed into the US Navy's purpose-built carriers had actually worked in real life. They started with a list of what they, in theory, would like to keep from the Yorktowns. Air group size, anti-aircraft battery, which included 8 5-inch dual-purpose guns, and operational range all went on that list. Now, to be fair, they did look at a number of options that defied this listing. The first one maintained all these features, but it turned out they had to sacrifice speed and almost all protection. Another kept up speed, but they had to sacrifice the air group to do so. Another ended up with Yorktown levels of protection, but cost massive amounts of speed and almost half the size of the air group, and an attempt to boost the air group with partial protection was also made, but that poor thing could only just about scrape in at 25 knots. It was also thought about using multi-level launching. This was thought to either save weight by cutting back on the upper flight deck, much as the early versions of Akagi and Kaga had done, and Courageous and Glorious would continue to do, or by just making the forward part of the hangar essentially fully open, using negative spacing to save weight. Just how desperate the designers were for extra tonnage for their ship is evidenced by the fact they successfully lobbied in getting the 350 tons worth of combined margins assigned to Yorktown and Enterprise to be transferred over to WASP before the Yorktowns were even fully built, and it wasn't actually clear if they need that displacement, and it turned out they actually did. Unsuccessful attempts also included asking for the flagship features of all previous carriers to be removed, which would save 100 to 150 tons, which could go on to WASP, with the flagship role then being transferred over to cruisers, as well as the removal of the 8-inch gun turrets from both of the Lexingtons, with the tonnage from the US's total allowance being allocated to WASP. It was also suggested to make the ship like Ranger and perhaps only carry fighters and dive bombers, which would eliminate the need for the larger torpedo bombers, as well as the torpedo storage and handling facilities entirely. Although it was clear that speed was going to have to drop in some manner, 25 knots was felt to be unacceptably slow. Just over 29 knots was considered a minimum. Now, this all added up to reverting essentially back to that original list of keeps, with Admiral King asking if perhaps if they exchanged some of the proposed catapults for some deck armour and torpedo protection, would this be possible to make the ship a little bit better protected? Now, the designers, to be fair to them, did do their best. They placed the magazines as low as they could in the ship, taking them entirely below the waterline, and adding some deck armour above both the magazines and the aviation fuel tanks. In theory, this should offer a modicum of protection against bombs and shells, but it also moved these facilities right into the prime target zone of torpedoes and mines. Now, at first it seemed that although anti-torpedo protection was thought to be completely out of the question, an armour belt and some more armour decking might be able to be incorporated to cover the machinery spaces, and the belt extended to also cover the magazine. This would offer at least some protection from more distant blast effects, if not entirely against directly acting ones like torpedo strikes. But as the design went on, this feature had to be deleted, although interestingly an STS steel backing plate was fitted in its place, apparently with a view to using this to install an armour belt onto the ship anyway if war happened to come, because then the treaties could be ignored. However, the primary aim of all these protection rearrangements was to guard against shell fire, which was still thought to be the major threat. And for all that, WASP still came out almost 1,000 tons over her target design weight, 700 tons over her final design weight, and almost 1,500 tons over the initial design weight before all the weight reallocation shenanigans from the other ships were factored in. At the absolute last minute, attempts were made to modify her power plant to reach almost 31 knots, but the cost of doing this in both time and money was seen as far too great, and the idea was quietly dropped. Unfortunately, of course, this meant that when she was sent to the Pacific, which was a theatre she was initially kept from because of concerns about her vulnerability, in order to replace carriers which had been sunk whilst carrying much more comprehensive protection systems, what happened to her was almost inevitable. Her ability to operate an exceptionally large air group for a ship of her displacement meant precious little to a submarine, and to be perfectly blunt, in 1942, even against Japanese carrier aircraft strikes, the large air group was of questionable value, until the coming of HMS Victorious, aka USS Robin, managed to sort out the US Navy's fighter control and direction situation. And so, with a lot of planes and some marginal protection against incoming shell fire, it was a trio of Japanese torpedoes from the submarine I-19 which blew massive holes in her side, and then started a series of huge gasoline fires and explosions which would doom the ship over the course of the next half hour or so. In retrospect, a carrier operating maybe 50 to 60 aircraft with a working torpedo defense system, or just a slightly rules-lawyered Yorktown repeat, would have been a far better idea. 50 to 60 aircraft on a carrier that survives is still far better than 90 on one that explodes. Although, to be perfectly fair to WASP, 3 Type 95 torpedoes might well have put down a Yorktown just as well, but at least there almost certainly would have been fewer fatalities, and the possibility of the ship surviving if it wasn't directly hit on the aviation gasoline tank. But that's it for this video. Let me know what you think, what other ships you think might fit onto a list like this, obviously bearing in mind we have covered 10 others in the first video of this type, and thanks very much for watching.
That's it for this video. Thanks for watching. If you have a comment or suggestion for a ship to review, let us know in the comments below. Don't forget to comment on the pinned post for dry dock questions.